Okay, then continue. Question 22b. In these questions here, they require us to first sketch the graph of y equals to fg, which is the composite function that we found in part A, where this composite function is happen to be a piecewise functions. Then hence, state the interval in which the fg inverse exists. So hence means that I must refer to the previous result and then I do something. So before I can solve the hence, let us try to find out the answer of the graph. Because maybe by just looking at the statement now at this moment, we don't know what we want to refer to get this answer here. So maybe after we sketch the graph, only we can see a better idea what we need to answer from the handstand. So based on part A answer, we happen to have the composite function defined in this way here, which is a piecewise function. And by the way, if let's say you happen to fail in exam or in your assignment, you fail to solve the part A, it is still all right that you can just apply the result from part A because they already give you direct from the show that it indicates to you the answer they would like to apply for the next part. So go on. For the case of piecewise functions, I will always happen to encourage you that you refer to what is the borderline value you have for the x in the interval here. And you can see the number here 3, it will happen to be the borderline value. So in the Cartesian plane, maybe you can start to put a dotted line there as a guideline for us to take notes that whenever later you sketch your graph, as long as you happen to see that it passed through this line here, you find out that there will be changes of function, or I should say changes of graph. It happens here. Okay. Then go on. So let us consider to sketch each of the functions here, and you will find out that, okay, let us try to do a rough sketch there before I put into this diagram here. So by the time I try to sketch the graph for the case of e power of x minus 3, what will happen I have is that, let's say, this is my x-axis. Then the graph will happen to look something like this. And the graph will happen to cut the y-axis somewhere. And in this case here, we can just have a quick calculation at e to the power of minus 3. And since the question is asking for this function here, e to the power of x minus 3, for the case of greater equals to 3, therefore, if let's say here is x equals to 3, I'm only interested with this part of the graph only, the part that I highlighted in blue. And this includes the point at the point x equals to 3. So if I substitute x equals to 3 inside here, I find out that I have the coordinate as 3, 1. So I want this part here, include the point of 3, 1, and all the way up here. Then before I plot into my piecewise function, let me also try to have a quick look on how is the full functions happen to look like when the time I have the case of e power of minus x minus 3. So I suppose this is happen to be the shape of the graph I have. And you find out that the y-intercept happens to be e to the power of 3. And by the way, both of the graph, you find out that they have the x-axis as the horizontal asymptote. And once again, I have the cutting point at 3. So I would like to have the value 3 in such that I want less than 3. I want the part less than 3, which means that this part here. And what will happen to be the value when the time I have x equals to 3, I find out that I also have the coordinate of 3, 1. But this time I don't want to include the 3, 1. And by the time you join these two graphs here, you find out that this is what you're supposed to have. The one in blue, the one highlighted in blue, include the point 3, 1, and also the one in green. And by the way, the graph that I happen to sketch it is not very good sketching because the part in green, right, is supposed to have y-intercept. In our graph sketching, I should show the y-intercept, but in here, I fail to show the y-intercept. So when the time you sketch, if possible, you give your y-intercept in, which means that if you try to sketch, maybe your graph will look something like this. And then please kindly show the y-intercept, where e power of 3. And this point here is 3, 1. This will be a better plotting compared to my graph here. So therefore, I have done the graphing part, and hence state the interval in which the inverse for the composite happen to exist. So this graph here I happen to sketch. This graph that I happen to sketch is actually the graph of composite FG. And the question said, hence, that means based on the graph that I have, I must come up with the answer, state the interval in which the inverse exists. So what is the criteria I need to consider here for the inverse to exist is that, okay, guys and girls, whenever we want to discuss about the existence of inverse, there is two conditions that we need to obey. First is the function must be onto. Second, the function must be one-to-one. And you find out that in our syllabus, most of our function, or I should say all of our function are onto. We always consider our function are onto. Therefore, there is no calculations that we require to consider on the onto part. We just focus on the one-to-one until you neglect about onto. You forgot about you need to have the criteria of onto. So therefore, as I say, all our function is onto, so we focus on one-to-one. So if I want the inverse to exist, I want the function to be one-to-one. And when the time I discuss one-to-one and I have graph, what can I happen to know is that based on graph, I can see whether a function is one-to-one or not. And in this case here, the full curve that I have, the full graph that I have here is obviously not one-to-one. It's because when the time you try to perform a horizontal line test, you can obviously to see that the graph will cut the horizontal line at more than one point. So the full piecewise function is not a one-to-one function, therefore inverse does not exist. However, I can still make this composite function to be one-to-one, and therefore the inverse happen to be exist where I consider the case such that, let's say I only consider the part highlighted in green, or I only consider the part highlighted in blue. So therefore, if I only consider the part highlighted in green, so the part highlighted in green for sure is a one-to-one function. To have a better visions, maybe I happens to erase the part in blue. Now you see this graph here is a one-to-one function. So therefore inverse exists. And for this case here, what is the interval that happens to evolve? It will be happens to be negative infinity until 3, but not include 3. I want to emphasize not include 3 so that I can have a very clear cut on which function to refer. Because for this function here, not equal to 3. So now if by just referring to this part of the piecewise, it is the case that one-to-one function and inverse exists if just refer to this part here. The same idea will happens if, let's say, I only refer to the part in blue, which is this one here, and take notes, it do include the point 3, 1. So this is what happened. It is also one-to-one, and it will also have the case that inverse exists. And therefore, it come to our conclusion to say that the inverse exists for the interval. The first one, negative infinity to 3, not include 3, or 3 to infinity. And please alert, the all here is not to indicate the case of union. Jangan melibatkan union. Dia adalah dalam bentuk ayat beritahu kamu ada dua choice. Choice pertama, choice kedua. And to have better explanations here, this is try to tell you that I can have the inverse to be exist when the time I either have the domain of the composite for negative infinity to 3 or the domain from 3 to infinity. Either one of the domain I take. then the inverse exists. This is what it's trying to tell from the questions here.